Today we are going to talk about statistics. We've done a little bit with statistics in the past. You've had it in past classes. We've got mean, and that is the average. So you know that probably is more common, but mean and average are interchangeable words. So to find the mean is where you add the values and then divide by how many numbers. So, you know, if you had 7 numbers, add them, divide by 7. The median is putting the values in numerical order. So once you put them in order, the middle number is the median. If you have more than one middle number, you find the average of those two. That happens when you have an even amount of numbers. You would put them in order, take the 2 that are in the middle, add them, divide by 2, and that will be your median. Mode is just the most occurring number. Does that have 2 R's? Then range, highest value, minus lowest number. So you're just finding how far apart your numbers are in all of the data that you were talking about. So these we need and we've used before, but we're actually going a little bit those things. The first is finding what we call variance. I'm going to basically just talk you through the steps, how to find it, what do you need to do, and then we'll try to talk when you're in my class about what it means, how to use it, when do people use it, because it's a pretty confusing concept. There is an actual formula, but the symbols tend to get confusing, so I'm going to wait on those and show you those when we're together. So what you want to do first when you're finding the variance for a set of numbers is find the average of the data. So you're just adding all of your numbers together, dividing by how many there are. After you've done that, you want to find the difference of each individual value from the mean. So essentially we're looking at how far from the average is each value. If the average is 4 and your first value is 1, the difference would be 3. It's 3 away. After you've done that for all of your values, you want to square each value from step 2 and then find the average. So you're taking the average again from step 3. So here is what that would cover this part up. Essentially what that would look, we had the data, the numbers 2, 2, 4, 5, 5, 5, 9, 10, and 12. So for this, our very first step, so step 1, find the average. So adding all of these numbers up, dividing by how many numbers there are, which is 9. When you add them, you get 54. Divide that by 9, and you get 6. So there's our average. So we'll go ahead and indicate that next to that 6. Now when you move on to step 2, since the average is 6, what you want to do is find the difference of each individual value. How far away from 6 is it? So for this first 2, it is 4 away, so -4. Second 2, that is 4 away. It's smaller, so we subtract 2 minus 6. 4 minus 6 is -2. And we keep going on, 5 to 6, so we'll have 3 negative ones in a row. Then we do 9 minus 6, which is 3, 10 minus 6, which is 4, and 12 minus 6, which is 6. So all of these are how far apart each one is. And if you look, I can kind of highlight it, maybe make it a little bit better as far as the visual, this number right here corresponds to how far that is from the average. And moving on down the line as we keep going, 9 corresponds to this one. 9 is 3 away from our average. Okay, so we move on now to step 3. And step 3 tells us to square all of these values. So remember, squaring means to multiply by it. So when we do that, -4 times -4 will give you 16. Again, 16. 2 squared is 4. 1 squared, 1, 1, 1. I'm sorry, -1 squared. 3 squared is 9. 4 squared is 16. 6 squared is 36. So these right here are all of our squares of the differences. All right, so this was the difference. These are all of those numbers squared. Now in our very last step, what we want to do, our 4th step, is find the average of all of these numbers. So you want to add everything up, the 16, 16, 4, 1, 1, 1, 9, 16, 36, and find the average of that. So again, there are still 9 numbers total, so we know that we'll be dividing by 9, because we're finding the average. So when we add those all together, we end up with, hang on one second, we get 100. All right, and we divide that out, and what we end up with is, and I'm going to round it, so instead of using an equal sign, use a little squiggly equal sign. Oops, it froze. Use a squiggly equal sign, which means approximately. So that right there is approximately 11.11. So this number right here would represent our variance for this above data set given to you right here. Okay, now variance leads directly into our standard deviation. So now with moving that term, all is take that variance, which we found right here, this 11.11. So we take that number and we're going to take the square root of it. So we have all of this, and there's just the one step. Our variance was 11.11. So to find the standard deviation, we will just take the square root of that number, and what that ends up being is 3.3 repeating. And really, more often than not, they tell you just to round to the 10th. So in this case, we can just say, if we are rounding to the 10th, our standard deviation for that exact same data set, remember we're using the same one as before with the variance, we're just continuing onward with it. Our standard deviation is approximately, and again I should not use the equal sign, I should use the squiggly equal sign, and that would be our approximately 3.3 for the above, or for the information that we had earlier. Now as we move on, we have variance and we have standard deviation. That's 2 of the 3 that we're going to talk about. We are moving on to another, which is mean absolute deviation. Okay, so this one is a little bit different. We still find the average of the data, so exactly the first step here with the variance, you're still finding the average. After you do that, you find the absolute value of the difference from the mean. So, what do, let me see if I can, it won't, okay, well, all of our numbers written out, so let me go ahead and do that a second time. 2, 2, 4, 5, 5, 5, 9, 10, and 12. So once we have that, and we know already from the previous finding the variance that the average was 6. So now, before with variance, we would say the difference, how far 2 is from 6, is -4. But since we're doing the absolute value, remember that that means how far away. We're talking about distance, so we keep it positive. So instead of the -4, we would write +4. So really all that does is change all of these so they're all positive numbers. So in our second step, we're doing the absolute value of our differences. So 2 to 6, 2 is 4 away from 6, and continue to work your way down until you get through all of the data. Now once you've done that, we are going to do our third step, which is finding the average of the values that we have right here. So again, average, adding and dividing by how many numbers there are. So before, with the variance, remember that we squared them and went on from there. Okay, so sorry, I ended up getting distracted. With these numbers, we find the average. With the variance, we had to square them and then do the average. We're not doing the squaring part anymore. We're just doing the average. So in our third step, we add all these numbers together, and we will again divide by 9 because that's how many there are. So we take all of those, and when we add them together, we end up with 24. When we divide that by 9, now again, this is an approximation. I'm going to go ahead and round it to the hundredth this time. So approximately 2.67. So this number right here represents our mean absolute deviation. And if you look at the name, mean, you already know that. It's average. We did the average right here. Absolute is our absolute deviation, or I'm sorry, absolute value, and we did that in our second step. So we're using both of those things to find this information. Go ahead and copy all of these things down. I know that it seems a little overwhelming. We are going to eventually need them because you will have all of these symbols on your calculator. You will have them in the formulas given to you for the tests. So I want you to have them written down, what they mean. This basically means you don't even need to know this. It's there, it doesn't matter. But we will actually talk about it in class together. We'll do the calculator portion together so that you'll actually see them. But at least you've already been introduced to them, and we can go from there. Ignore that. We want to do this again. We'll go ahead and move on and do this group of info. So if we wanted so we're finding the means and the standard deviation. If we would like to find the variance, remember you have to find the mean first. So these are all the dog's heights, and you see how they line up. So we add everything, each height together, and they did shoulder height. That's what the red arrows are for. We divide by 5, because there's 5 dogs, so we get 3, which represents our mean, our average. That information, this green line right here, is what that average is. It's showing you right there. So essentially our next step in finding the variance is to find how far away each number is from this line. So when they take the dogs out and just have the red line, we're looking at how far apart is the green line from where the red is. And you do that for all of your values. So we'll have to do that 5 separate times. So when we do that, we end up with this number here. 206 squared, 76 squared, and notice with the negative 224, they put it inside the parentheses, squared, square the 36, and then again negative 94 inside parentheses, square it. We get these values, all these values, we divide by 5, we end up with 21,704. That is our variance for this information here. Now moving on, once we have the variance, to go to the standard deviation, you're just taking the square root. Simple square root of the 21,704, get 147.32, And in the problem, let's see, everything was measured in millimeters, so we're going to keep it consistent and not just keep it in whole numbers, so we round to 147, so that's the standard deviation. So this just kind of breaks it down to help you get a better sense of what exactly that means. So 147 millimeters from the average, both above and below, is where most of the dog's heights will fall. And if you look at this dog does not. It's outside of the standard deviation. However, this one does, and this one does. Again, this one is below. So it's saying most of your information will fall between these blue lines, and in this case it does. 3 out of the 5 dogs fall in that. Alright, so from here, once you get into class and practice some of these variance and fine deviation, what the symbols, we'll work with the calculator some more, do some more practice problems, see how it works from there, and write down any questions that you have for me, and hopefully we will get through this pretty easily.